When you are standing under the relentless, sweltering midday sun, the heat feels like a physical weight. Your body struggles to shed thermal energy, and finding a way to cool down becomes your only priority. Today, we solve this problem by retreating indoors and flipping a switch. Since Willis Carrier popularized the electrical air conditioner in 1902, we've engineered our way out of the heat using raw mechanical power. This diagram illustrates exactly how that modern system works. We pump massive amounts of electricity into a closed loop, driving a compressor that forces chemical refrigerants through coils to chill the surrounding air. It is highly effective, but demands an enormous power grid. But for thousands of years, civilizations thrived in some of the most scorching climates on Earth. The ancient Egyptians, Persians, and Chinese built empires in the desert, centuries before the invention of the electrical grid. Their architects didn't have compressors or chemical refrigerants. Instead, they manipulated physics, engineering passive cooling structures so sophisticated that modern designers are actively studying them to build better cities today. The most accessible tool for these ancient engineers was evaporative cooling. When liquid water turns into gas, it absorbs thermal energy from the surrounding air. The vapor drifts away, and the air left behind naturally drops in temperature. The ancient Egyptians applied this principle around 2500 BC. They hung wet reeds in their doorways, forcing desert wind to pass through the moisture. During the Tang Dynasty in China, the emperor built a massive specialized cool hall. It featured towering, water-driven rotary fans and massive fountains that sprayed mist into the air, creating a continuous, refreshing indoor climate. Wealthy citizens of the Roman Empire diverted frigid water from the city's aqueducts directly into their walls. This moving water absorbed the heat radiating through the stone, dropping the ambient temperature of their living spaces and public baths. Controlling water evaporation gave ancient builders a highly effective thermal tool. They turned a basic chemical phase change into an active architectural cooling system. While liquid water is highly effective at absorbing heat, you still need a way to circulate the naturally cooled air. Persian engineers built structures called bodgirs, or wind catchers, to manipulate air pressure without moving parts. A wind catcher intercepts cooler, high-altitude air. High pressure forces it down the central shaft. At the bottom, it rushes over an underground canal, dropping its heat into the water. The cold breeze then sweeps upward through the living spaces, venting out the opposite side. By combining high-altitude capture with subterranean moisture, Persian architects engineered a continuous loop of pressure that channeled harsh wind into a freezing breeze. Moving air and evaporating water can drop the temperature of a room, but keeping highly perishable foods near the freezing point in the dead of summer requires a completely different, specialized approach. To achieve this, ancient Chinese builders constructed lingyin, or ice cellars. Ruins of these structures were excavated in the ancient cities of Yongcheng and Zhonghan. This technical drawing of the Zhonghan excavation shows these chambers buried deep underground. The exterior was wrapped in thick rammed earth masonry to limit thermal transfer. To prevent accelerating ice melt, the floor features 5 vertical drainage shafts, labeled J1 through J5, wicking meltwater directly away. Builders sealed the cellar from the hot surface using thick layers of straw and mud. These engineers utilized the massive thermal inertia of the Earth itself, essentially treating the ground as a giant thermal battery to hoard the freezing temperatures of winter all the way into August. For the last century, we have largely abandoned these techniques. Instead, we rely heavily on mechanical compressors to keep us cool, driving up energy costs and straining power grids globally. But in Jaipur, India, the Pearl Academy stands as a modern architectural marvel. It integrates the ancient physics of evaporation, aerodynamics, and thermal mass into a contemporary design. To mimic ancient ice cellars, the roof is embedded with hollow clay pots. The stagnant air trapped inside acts as a natural insulator, blocking intense solar radiation. Next, an open central courtyard creates stack ventilation. Hot air naturally rises and escapes, creating a low-pressure zone that actively pulls cooler, fresh air in below. Finally, that incoming air passes over shaded water bodies. The water evaporates, absorbs thermal energy, and delivers a naturally refrigerated breeze into the classrooms. The Pearl Academy proves that we don't always need to fight the environment with brute force machinery. By understanding the physics of our surroundings, we simply let nature do the work for us.